It's a dream, isn't it? The ultimate developer fantasy.
Oh, yeah.
You describe the feature you want. Maybe you sketch it out. Maybe you just vaguely gesture at a whiteboard,
Yeah.
and then you hand it off. You go grab a coffee.
Right.
And by the time you sit back down, the code is just there,
Yeah.
written, tested, and waiting for you.
That is the promise of the autonomous agent, for sure. It's not just a tool anymore. The whole narrative has shifted. We're not talking about a spell checker. We're talking about a digital coworker.
Exactly. We've moved past AI as a helpful assistant. We're squarely in the era of AI as the intern who never sleeps. But here's the problem with those narratives. They usually run way faster than the reality.
Mm-hmm.
And we've been operating on a lot of hype and, frankly, very little hard data.
Which is why today's deep dive is going to be a bit of a reality check. I think a necessary one.
Absolutely. We are looking at a brand new paper submitted to Archive on January 20, 2026. It's titled AI IDEs, or Autonomous Agents, Measuring the Impact of Coding Agents on Software Development.
By Shyam Agarwal, Hauhi, and Bogdan Vasilescu.
And honestly,
Yeah.
the results are not what I expected at all.
No, there's some genuine curveballs in here. What makes this paper stand out to me is the methodology. They aren't just, running agents on benchmark questions.
Right, like asking it to write a snake game in Python and seeing if it compiles.
Exactly. Because passing a coding interview is very, very different from maintaining a massive enterprise code base with 20 other people.
So what do they do?
This is a longitudinal causal study. They used the AIDev dataset to track real-world open-source repositories over time. They watched what actually changed in the code when teams went from standard AI assistants to these full-blown autonomous agents.
And the mission for this deep dive is to answer two really specific questions from that data. First, does handing the keys to an agent actually make you faster? And second, and this is the big one, what's the cost of that speed?
Because there is a cost. And it's not paid in dollars.
Yeah, it's paid in what you call complexity debt. Ominous. I love it. But before we get there, we need to clarify our terms. The title of the paper pits AI IDEs against autonomous agents. For a lot of people, those might sound like the same thing.
But in this study, that distinction is everything. It's the fundamental variable.
So let's break it down. AI IDEs.
Think of AI IDEs as the incumbents. This is what most developers have been using for a few years now. The tools integrated right into their code editor.
The autocompleters.
Exactly. Like Copilot in its early forms. It's like a really advanced GPS. You're driving the car, your hands are on the wheel, and the AI says, hey, maybe turn left here.
Okay. But if I stop typing, the car stops moving. I'm the engine.
Correct. You are the engine. The AI is the navigator. Now, contrast that with the autonomous agent.
Newcomers.
Right. The paper calls them autonomous contributors. The whole mindset shifts. You aren't typing code. You're assigning a task. You say, fix this bug, or add a payment gateway. The agent reads the code, plans the changes, writes the code, and this is key. It creates the pull request.
So I'm not driving anymore. I'm in the backseat reading a magazine.
That's the idea. And the study defined adoption as the exact moment one of these agents successfully generates a pull request in a project.
Which brings us to the methodology. You said this was a causal study.
Yeah.
And I always get a little skeptical when I see that word. How do you prove the tool caused the change?
Right.
Maybe the team just hired a really good engineer that month. Or maybe there was a deadline. How'd they filter out that noise?
They used a pretty clever technique. It's called staggered difference and differences with matched controls.
Okay, you're going to have to unpack that. That sounds like a spell from a statistics textbook.
It does sound intense, but the logic is actually quite elegant. So imagine you have two software projects, Project A and Project B. They're matched, meaning they're basically twins. Same language, similar size, similar history.
Okay, so we have our software twins.
Now, Project A adopts an agent in June. Project B doesn't. You don't just look at Project A and say, wow, their speed went up by 10%.
Because maybe everyone's speed went up in June.
Exactly. So what you do is you look at the difference in Project A's performance before and after adoption. Then you look at the difference in Project B's performance over that same period.
And then you compare the two differences.
You compare the difference of the differences. It isolates the impact of the tool itself. And staggered just means they did this for lots of projects that adopted agents at different times.
That is actually pretty robust.
Yeah.
It's as close to a lab experiment as you can get in the wild.
It is.
So let's get to the results. Let's start with velocity. Speed. That's the sales pitch, right? 10x your engineering team.
That's the promise.
If I'm a manager buying these tools, I expect that graph to go up and to the right immediately.
And if you just look at the raw numbers, it sort of does. But when you apply that rigorous filtering, the picture gets, well, it gets complicated. The authors found what they call heterogeneous effects.
Which is academic for it depends on who you are.
Precisely. They identified a phenomenon they call the first hit effect.
First hit. Sounds like we're discussing something illicit.
Well, the dopamine rush of seeing code just appear might be similar. The study showed that for projects that had never used any AI tools before, total purists introducing an agent resulted in a massive, statistically significant spike in throughput.
So for the AI versions, it's a rocket ship.
Yeah.
That makes sense. You go from manual labor to automation. Of course you're faster.
However, and here's the twist, for repositories that were already using AI IDEs, so teams already using Copilot or something similar,
Yeah.
introducing an autonomous agent resulted in, and I'm quoting here, minimal or short-lived throughput benefits.
Wait, really? Minimal?
Minimal.
But that feels so counterintuitive. If I'm already fast with an assistant, shouldn't an autonomous agent make me even faster? Why is there a ceiling?
That's the multi-billion-dollar question. The paper suggests one reason is, low-hanging fruit.
Yeah.
The AI assistants have already automated the easy stuff, the boilerplate, the standard functions. You've already gotten the easy speed gains.
So the autonomous agents are trying to tackle the next layer up, the harder problems.
Exactly. And frankly, they struggle more with that. But there's also the integration cost. Think about it. When an assistant suggests a line of code, you verify it in a split second.
Sure. I see it, I hit tab, I keep going, it's part of my flow.
Exactly. But when an agent submits a pull request with 500 lines of code across 6 different files, you have to stop.
Oh.
You have to switch context. You have to review it, understand it, test it.
It's just the bottleneck. You're not spending your time typing, you're spending all your time reviewing.
You're trading writing time for reading time. And as any developer knows, reading someone else's code, especially a robot's code, is often slower than just writing it yourself.
Which is the perfect segue to the second part of this study, the part that's actually, I think, more alarming.
The quality.
The quality. Because
Yeah.
if the agents aren't making us that much faster, you'd at least hope they aren't breaking things.
This is where the red flashing lights start going off. The researchers found that while speed benefits were conditional, the negative impact on code quality was, quote, persistent across settings.
It didn't matter who you were.
Didn't matter. The quality dropped.
Dropped how? Are we talking about, like, syntax errors?
No, the code usually runs. That's the dangerous part. It works, technically, but the structural integrity just degrades. They tracked a metric called static analysis warnings.
Those are the automated flags, right? The little squiggly lines?
Yes. Things like unused variable or potential null pointer exception. Security vulnerabilities often show up here too. The study found that after adopting autonomous agents, these warnings rose by roughly 18%.
An 18% increase in potential bugs. That's not a rounding error. That's a trend.
It is, but there's another metric that I think is way more damning. It's something called cognitive complexity.
Cognitive complexity. What is that?
It's a measure of how difficult it is for a human brain to understand the control flow of a piece of code.
So basically, how hard is it to figure out what the heck is going on?
Exactly. Simple code is a straight line. Do A, then B, then C. High cognitive complexity is a bowl of spaghetti. If this, then that, but loop back around if this other thing is true.
The kind of code that makes you just squint at the screen for an hour.
Right. The study found that code generated by autonomous agents increased cognitive complexity by roughly 35%.
35.
35%.
That is enormous. I mean, if the difficulty of my job went up 35% overnight, I'd quit.
And think about what that means. Code is read 10 times more often than it's written. If you make it 35% harder to read, you are taxing every single future developer who has to touch that file.
You're slowing down every future bug fix, every future feature.
Absolutely.
Why does the AI do this? Is it just bad at its job?
It's because the AI doesn't understand the problem. It predicts the next most likely token. So it might write a massive convoluted if-else chain because that's statistically probable, whereas a human would step back and say, wait, this is messy, I should just create a separate class for this.
The human refactors for clarity. The AI just finishes the task.
It wants to get to the solution. It doesn't care if the path there is a tangled mess.
The authors had a great term for this, didn't they? Agent-induced complexity debt.
It's a brilliant term. We've always had technical debt shortcuts we take to ship faster, but this is specific. It's the cost of letting a non-human entity structure human logic.
And it feels more dangerous because you take on that debt silently. You might not even realize how bad the code is until 6 months later when you have to change it.
That's the trap. The agent says, task complete, the tests pass, the feature works. You merge it and you feel productive. But you've just injected a block of concrete into your foundation.
And didn't the study also mention code duplication went up?
Yes, significantly, which is a maintenance nightmare. If there's a bug in that logic and the agent has pasted it in 4 different places, you have to find and fix all 4.
So let's just recap the scorecard here. If you're an experienced team, you get minimal speed gains. But in exchange for that, you get 18% more warnings and code that is 35% harder for any human to understand.
When you put it that way, it's a terrible deal.
This sounds like a scam. So why is the industry rushing this way? Are we just blinded by the novelty?
I think we're blinded by the creation cost. We're obsessed with how fast we can write code. And these agents drive the cost of writing to near zero. But software engineering isn't about writing code.
It's about maintenance.
It's about maintaining a living system. For years, we are optimizing for the easy part and making the hard part exponentially harder.
So the author is saying we should just ban these things, go back to the old way?
No, I don't think that's realistic. The genie is out of the bottle. But they do offer 3 very specific safeguards. They argue that if you're going to use these tools, you need to change your process.
Okay, what are they? How do we survive this?
Recommendation 1, quality safeguards. And this means automated, ruthless gates in your pipeline.
What do you mean?
You can't just rely on a human to skim the code. You need strict, automated rules. If an agent submits code that increases the complexity score beyond a certain threshold, rejected automatically.
So the robot gets told no by another robot.
Essentially, yes. You force the agent or the human prompting it to simplify the solution before it ever gets merged.
That makes sense. It's like putting a governor on an engine. What's number 2?
Provenance tracking. It's a fancy way of saying we need to label the ingredients.
Right.
We have to know, for every line of code, was this written by a human or an agent?
But why does that matter? Code is code, right?
The computer doesn't care, but the human debugger does. If I'm hunting for a bug at 2 in the morning, I approach a block of code very differently if I know Dave wrote it versus if I know Agent 007 wrote it.
Because you assume the agent's code might be unnecessarily complex or just plain weird.
Exactly. It acts as a warning sign. Caution. Machine-generated logic. It tells the next developer to be extra skeptical.
And the 3rd recommendation.
Selective deployment. Basically, don't use agents for everything.
Right. Don't use a flamethrower to light a candle.
Use them for boilerplate, for writing tests, for documentation, the tasks where complexity is naturally low. But maybe keep the humans in charge of the core business logic, the architecture, the important stuff.
It's so interesting. The marketing all says autonomous. But the data says the real solution is micromanage.
That is the paradox of automation. As the tools get more powerful, the human supervision needs to get stricter. We're moving from being bricklayers to being building inspectors.
And it's a lot harder to inspect a building that was thrown together in seconds by a swarm of drones.
Especially if the drones decided the bathroom should go on the roof, because statistically, that's where some rooms go.
Right. Most houses have stairs, so put some here. There was one last thing that stuck out to me, that first hit effect.
Mm-hmm.
It feels like a massive trap for new companies, for startups.
Oh, absolutely.
You can picture it. 2 founders, they use agents for everything. They build their whole product in a week. They think they're geniuses. But they've built the entire thing on that 35% higher complexity baseline.
They're building on quicksand.
Right. And then 6 months later, they try to pivot or add a real feature, and they find they can't move. Their whole code base is an unreadable mess of agent-generated spaghetti.
That's the legacy code from day one scenario. Usually it takes 10 years for code to rot. Now we can generate rotten code instantly.
Instant legacy code. That's a terrifying phrase.
It is. It creates a false sense of progress. You have features, but you don't have maintainability. And in the long run, maintainability is the only thing that matters.
So what's the verdict? If you had to summarize this for everyone listening, what's the one big takeaway?
The takeaway is that velocity is a vanity metric.
Ouch.
It is. If you're optimizing for lines of code per day, you are driving your project off a cliff. You need to start optimizing for maintainable features. You need to watch that cognitive complexity score as closely as you watch your revenue.
Put the brakes on.
Refactor. Simplify. Don't let that debt compound. Because the interest rate on agent-induced complexity debt is incredibly high, and it will bankrupt your development cycle if you're not careful.
It really changes the framing. These aren't magic wands, they're power tools. You can build a house faster with a nail gun, but you can also put a nail through your hand much faster.
A perfect analogy.
We've covered a ton of ground here. We define the difference between the helpful assistant and the potentially dangerous autonomous agent. We debunk the myth of infinite speed.
And we uncovered that hidden cost, a 35% spike in complexity that creates a maintenance nightmare.
It's a classic case of faster, better, cheaper, pick two. The agents give you faster and cheaper, but better takes a massive hit.
And in software, not better eventually means not faster either.
So as we wrap up, I want to leave you with a thought. We are rushing toward a future where software writes software. It feels inevitable. But this data suggests we might be rushing toward a future where no human actually understands how the world works anymore.
A world of black boxes talking to other black boxes.
Exactly. If we fill our digital foundations with complexity,